Hey guys, what's up? It's Glorious Liar. Today I am going to be going over how to modify setup files in DK64. Um, a lot of people have recently played and given me feedback about a ROM hack that I just came out with, DK64 Conquest. And I basically did it completely by myself in terms of actually doing the work to like edit the files and actually modify the ROM. Um, a lot of people already know some of the required knowledge to do some of the stuff I'm about to explain, but I thought it'd be good to sort of document some of the stuff that I did, so that people in the future can get into ROM hacking DK64, which I think is a good goal. Um, so first to start off, I have my BizHawk emulator running Donkey Kong 64. Um, and you'll see a bunch of information here. That is output from ScriptHawk, which is a Lua script that Isotarge has made for, um, well, it works for a lot of games on the N64, but specifically for Donkey Kong 64, it has a lot of features. As you can see, if you look at this little window right here, this is all DK64 specific stuff. And if I hit the left arrow on here, um, you can see some of the stuff that we're actually able to go in and modify. And there's a ton more stuff that you can spawn in if you know what you're doing, which by the end of this video, hopefully you'll understand. But as you can see, we have objects like the Trophenskopf feed pad, which is probably this thing right here. You got the Kong pad. I'm not sure exactly what all these are. You got like flames, um, a spawner for the tag barrel, which puts the tag barrel object into the world. Uh, Strangely enough, there's a spawner for B-Locker and Trophenskopf. Funny enough, but oops. If I resume emulation, I can actually show you guys some of these things. So, like, this object in memory at this specific address is this flame. And ScriptHawk is really useful because it outputs all this stuff and tells you all the stuff that's within the setup file for this specific map. But not only that, there are hotkeys to like move around and warp directly to objects based on their position data. So like if you want to go to Chunky's banana count pad, that's over here. Or if you want to go to the Trophenskopf feed pad, right here. So stuff like that. The stuff that's contained within the setup files, there's a couple things that are actor related, like tag barrels and B lockers and stuff that has like typically stuff that has very special characteristics in the way that you interact with them. And then what we call Model 2 objects, if you're not familiar with that, but it's basically stuff that I'm not sure exactly if you'd consider them actors, but stuff that's more, I don't know the best way to describe them, other than I guess I could show you more examples. So let's go to Jungle Japes. That's another good feature of ScriptHawk, is you can just warp directly to a map if you want. And let me filter by Model 2 objects, and then you can see, okay, so you got a ton of stuff in here. You got golden bananas, you've got flowers, tree stumps, colored bananas, torches, just a bunch of stuff. And so this is all stuff that we're able to actually go in and dictate where they spawn on every map load. So just to get started and to do a quick little demo, I want to go back to Trophenskopf because it's a good small map to show things off. So first off, if you look at the output here, and I go back to map object, ScriptHawk is really important for this, by the way, because this object analysis makes it really easy to go in and know exactly what you're modifying. And when you put something new in, this will update in real time, so you can actually, so you can double check yourself if you're just like inputting data into this Hex Editor on the side, which is RAM right here. It's not always, you're not always going to be 100% sure that you did it correctly, but this output on this screen over here really helps. So if I go to, well, first of all, if I go to 4fdad4, that's the first object that's spawned within the setup file. And you can see that the setup file starts right here, and it continues for a while down after this. And the way that the setup file is laid out in memory, to go over that first, you're going to have 4 bytes at the very start that signify the number of Model 2 objects. So I guess I could write it over here for clarification. So first, so the first 4 bytes is number of Model 2 objects. Okay, and then I have a little handy image that will help illustrate. Okay, and so then the Model 2 objects within the setup file they take up 0x30 bytes of space per object. So then if we call this number that's here n, then there's going to be 0x30 times n Model 2 objects here, and then you're going to have another 4 bytes. This is all sequentially within RAM. And then these 4 bytes are going to specify some mystery object that we don't actually fully understand yet, but we haven't really been able to figure out what it does or do anything cool with it yet. So you can do everything else with just actors or Model 2 objects. So this is going to be 4 bytes that represent the number of mystery objects we can call M. And then you're going to have, and then this one is size 0x24. So you're going to have 0x24 times M mystery objects. And then finally, you're going to have another 4 bytes that say number of actors. We can alter that O. And then you're going to have 0, and then actors are, I think, 38. Yeah, 0x38 times O actors. So if you go back to this example on the Traffenscoff map, the very first word contains 0x10, which is, so it's saying that there's 16, this is in hexadecimal, by the way, you have 16 Model 2 objects, and so if we, and then you'll see the first one immediately after that, and this is the 30 bytes that it contains. And so if we count down 16 of these, we can find where the number of Model 2 objects is, or mystery objects is. So this is the first one, and then we have the second one, third one, fourth, fifth, sixth, seventh, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so this should be the last one. And then this word right here, wait, no, it's this one right here. Okay, so this is the one that represents the number of mystery objects, which is 0. So if one of these is 0, then it will immediately go to the next line. So if you have 0 Model 2 objects, the next word will be number of mystery objects, and if that's 0, it'll go to the number of actors immediately. So basically all I'm saying is this block doesn't take up any space at all, and it will immediately go to number of actors if this is 0, which it is. So then you look 1 over, which is 2. So there are 2 actors on this map. And then those take up, 3, 8. So if we count that down, that's 1, 2, 3 plus that. Okay, so then this is like 1 actor right here. And then we go 1, 2, 3 here. And so this is where it ends. And then you got more stuff going on down here. But as you can see, there's sort of a pattern to it, so you can tell that this is the end of it also by this data is not at all like the data above it. And also we can double check ourselves by looking over here, and we see the first 1 through 16 objects on the feed are Model 2 objects, and then anything that's going to be an actor is going to be prefaced with spawner, because really what's being specified in the setup file is not actors, but actor spawners, stuff to be loaded into the actor spawners. So just like I said, there were 16 Model 2 objects, and there were 2 actors, and no mystery. The mystery I don't think would show up in the feed, because I don't think there's any display for that at the moment, because we don't really do anything with that at the moment. But yep, so basically everything that I just said about this block matches up with what I thought it would do. So if we go back to the beginning, if I give an example, so the first object is the trough and scoff feed pad, and these 3 words right here represent floats for the X, Y, and Z position. So if I were to just go into memory and directly just change those to 0, you'd think, wait, is this the beginning? Let's see, 4FDAB4, just double checking myself. I was on the wrong line. This is the trough and scoff feed pad. So if I was to go in here and set these all to 0, you would think that this positions would get updated in real time, but actually that's not the case. You can see that it remained in the spot that it was. This setup file here, it gives information to some code that runs on map load to actually put these Model 2 objects in the world, but I'm not actually sure how to update, or if it's even possible to update Model 2 objects in real time. I'm sure it is, but I don't actually know how to do that at the moment. And so you'd think, well, okay, if we can't update like its position or its rotation, or like what type of object it is, well then are we stuck? Do we have to modify the ROM and then go through the entire boot of the game and then enter a file, go to the map that we just edited in order to see the changes that we made? That would be like an incredibly long and tedious process, which I'm going to actually show you a way to bypass that. So like, for example, if I were to freeze these values and then force a transition by hitting force zipper, this will actually just, on most maps, if I hit force zipper, it'll just take me back to the map I'm already on, because you're not updating like a map to go to, so it stays the same, but you are initiating some sort of map transition, which is nice. It's a nice little way to just reload the current map you're on. And if you look, if I walk over here, you can see the pad is gone. And if I warp to it, you can see my position is at 0, 0, 0, but it's probably not going to want to cooperate if I go too far in advance there. Okay, so we know that there's some window in which we can actually update the parameters for these objects in memory, where they actually will get updated. and it happens somewhere in the midst of a map transition. Now there's a problem with this where this block of memory that we're editing in, it's dynamic, or the pointer to where this block is changes, and so the setup file pointer could actually be pointing to an area in memory that is occupied during a map transition, which is unfortunate because that means you can't just freeze these values. They might be they might be important, and freezing them could cause the game to crash or not load or something to that effect. So there is actually, to my understanding, there is actually a 1-frame window on a map transition where you actually are able to go in and update the values that you want, and simultaneously it's past the point at which it will matter if you're actually like going in and modifying data there. So like so this is like currently, so the setup file is currently pointing to here, and if I were to do a map transition like I just did, and nothing in this block of memory changes, which is fortunate. And what's also fortunate is the fact that my map transition that I just initiated doesn't actually update the setup file pointer, and it just wants to use this same block. That is just coincidental, and it doesn't always work like that, but with the power of save states, you can know ahead of time where it's going to point to, and then you can just go start editing data in the place that it's going to point to. So let me go to a map where I'm pretty sure that it will, this sort of stuff that I'm talking about will actually matter, and we need to sort of be careful about the way that we freeze values in RAM, because the goal here is to be able to go in and actually like modify this and say like let's see, 4FD AD4. So the goal here is to be able to go in and be like, I don't want there to be 16 on this map. I actually want there to be 17 on this map. And then I can go in and then I can go, okay, instead of 0x10, I'm going to put 0x11 here. And then somewhere down here in RAM, I can, add an object that's 0x30 in length, and then that will get spawned the next time the map loads. So that's the goal here, and that's sort of what we're going for. So I want to go to Training Grounds. Training Grounds is a good place to test this sort of stuff out. So as you can see, like, look, this area in RAM that was just being pointed to is now filled with a bunch of this stuff. I don't know exactly what it's doing here, but you can see that it's being dynamically updated. And now let's see. Now the first object is at 4A9, 1D4. And if I go there, here you go. Here's the setup file. Okay. Oops. Okay, and also conveniently on ScriptHawk, we have a way to like filter on this this stuff on the right side. So, say I only want to look at like the trees in this output, then you can just type in tree, and then it shows you where all the trees are in memory, which is nice, because something that's useful about that is, like, say we're just messing around and we want to change the type of a object and we want to like see what it looks like. Well, I can just say I want to change this tree, so I know. So without updating the position data, without updating the rotation data or the scale or any of that, I'm gonna know if I just change the type of this from tree to something else, it's going to spawn at roughly this location, which I know where this is relative to the tree house, so I can just walk right back here and then see the update. So if I go to Oh, I also wanted to show off, make a safe state. If I force zipper here, I want to see if, yeah, okay. So if I do force zipper here to reload the current map that I'm on, I'm going to show you that this, conveniently, this setup file is in the same location in memory, but at some point during this map transition, this block is going to be occupied by something else, but then it will immediately return back to being setup file related. So we can't just go in here and like freeze all this data. I mean, I could show you what it does. It'll probably crash, or not necessarily crash unrecoverably, but probably won't like it. So yeah, as you can see, the transition isn't happening because I froze all this data. So in order to avoid something like that, first I'll show you like what it sort of looks like in slow motion by doing frame advance. Okay, so if I make a safe state here, and then I just keep frame advancing until it gets occupied by something. Okay, now it has just transitioned. And then if I do one more frame advance, it changes to something else. I'm going to do another. Now it's back to setup file. So this is the exact frame where it goes back to being a setup file. And conveniently, this is also the exact frame at which I can go in and modify this data, and it will show up whenever the map eventually loads. So I'm going to demonstrate that. I made a safe state here. I'm going to demonstrate that by zeroing out all the data in the setup file. So by doing that, everything that's in this list, all the Model 2 objects, all the spawners, they are all going to be gone the next time I load this map. And as you can see, if I just jump off this treehouse right here, here's a tree, here's another tree. You know, there's a bunch of plants around. There's a tree there. You know, there's a bunch of stuff that's all around. But if I were to go into the setup file, and this is the beginning of it. So if I were to set this to 0, this is saying, okay, number of Model 2 objects is 0. Okay, and so then it will move on and be like, okay, how many mystery objects then? I'm also going to say 0. And then it's going to say how many actor spawners, and then I'm going to also say 0. So if I just zero out these 3 words right here, nothing's actually going to spawn on this map other than, you know, the basic layout. And wouldn't you know, look, all the trees are now gone. Nothing over here. Nothing over here. It's relatively empty. So as you can see, I just modified a setup file in real time without actually editing the ROM. And we'll get to editing the ROM later, but this is the fun part. This is the part where you actually get to go in and test your designs and get everything set up exactly how you want so that you can go in and you can modify the ROM. Confident that when you actually boot up your new ROM, it will behave like you want, and all the stuff will be in the right place and be the right size, the right rotation, everything. And another thing that I sort of glossed over is like what exactly we have the power to change. So this is not comprehensive by any means, but if you look, let me go back to like what the setup file looked like originally, and I'm also going to put this right beside it. So, so there are 0x5D Model 2 objects in training grounds, which is a lot. That's about 90 or so. If you look, they're going to, the size is 0x30, so every 3 rows at this offset, it's going to be the start of a new Model 2 object. And relative to the beginning of any given Model 2 object, let's just take one at random, like this one right here. So this is in RAM, this is an entire Model 2 object within the setup file. And relative to this beginning right here, we know that at offset 0 is going to be the X position. At offset 4 is going to be the Y position. At offset 8 is going to be the Z position. And then scale comes right after that. And then there's a bunch of stuff in the middle that is kind of hazy. We don't exactly know what all of it does. And a lot of it is also dependent on what exactly you spawn in. So for the most part, you can sort of ignore the stuff in the middle, because if you just want to, like, say you just want to go in and you want to place a tree or something, it's going to behave pretty normally if you just set its position, set its scale, set its type, and then leave everything else as 0. That's pretty convenient. So as a demonstration, well, first let me find a tree that we can mess with, and this will be our special tree that we keep messing with. Okay, so this is the tree, and it's at 4A93B4. Okay, so this is its X position, Y position, Z position, scale, a bunch of stuff, not exactly sure what this signifies here. And then you get to this one where it is the type. And this type actually only takes up 2 bytes, not the whole 4 right here. But we can go in and we can modify it. And let me just go in here and change it, and you can see, is this it? Maybe it's not that, maybe it's this. So it's at 0x128. No, it is this one. It's not actually updating. Maybe 9. Hold on. Maybe I'm just doing this wrong. Okay, so yeah. Let me just reload this and see what's up. Okay, so if I zero out this whole thing, okay, yeah. So the type is contained within this. Let me see if exactly I was doing wrong. So it's not that. Oh, it's 6C. Oops. Okay, so that means it's still a tree. I'm pretty sure the tree type is this, the 006C. I don't know, it's just behaving weird. Okay, so if I zero it out, it's no longer a tree, so it disappears from that list. But if I put it back here, okay, it's a tree again. Okay, I don't know what I was doing wrong the first time, but here we go. Okay, so as you can see, this 2 bytes right here represents the type. And what I'm going to do is I'm going to go into DK64.lua for ScriptHawk, which it's an enormous file. Let me just go to the raw of this because I don't want it to lag or anything. And if I Control F and I think of, like, okay, I just want to find a list of all the various objects that we have to work with. Let me just find a tree. Nope. Okay, here we go. Object types. And then, well, let's just look. So in RAM here, it was 6C. So let's find 6C in this list and go, okay, look, yeah, look, this is a tree right here. So if we look at this list, conveniently, and by the way, this is on GitHub. You can just go to the ScriptHawk repository, which is managed by Isotarge, and you go to the DK64.lua in the games folder. You can just find this and see all the stuff you're looking for. So the goal here is we're going to change the 2 bytes in that setup file to something else that we want to work with. So let's set it to something fun. Let's set it to that's a good one. Let's set it to a boss key. That's cool. We can spawn a boss key. Okay, so if I saw correctly, it was 13C. So I'm going to change this part to 13C. Okay, you can see this tree disappeared. Now let me... Oh, but now you can see it's a boss key. So if I load my save state and I freeze that value to what we want it should have updated. Oh, look at that! That's an enormous boss key. Wow. Isn't that cool? Let's see if we can collect it. Oh, we can. Look at that. Okay. Alright. Mission accomplished. Okay, and now let's say, well, that key, that's cool, but it's a little big, don't you think? So why don't we see if we can scale it down. Okay, so the scale, this is the beginning of it. So this is the X, this is the Y, this is the Z, this is the scale, based on that image that I showed you earlier. So you'd think, okay, what is 3F8? What are all these numbers? These don't look like position or scale values. Well, these are the hexadecimal representations of floating point, or decimals in game. So these are floats, and if we want to work with floats, what I like to do is I like to use a handy dandy converter. So if you look, I can go in here and I can type in what's in RAM, and it will spit out what that represents. Okay, so 3F800000 is 1. Okay, so 1 is too big, so what if we halved it? What if I do 0.5? Okay, so then that's telling me that 0.5 in hexadecimal is this. So I'm going to go in and I'm going to change that. So you can see it was 3F8000, now it's 3F0000. Okay, so let me reload the map and see what that did. I have a controller here, by the way, to mess around. Okay, so you can see it's a lot smaller. Not as small as we'd like, but definitely smaller. Let's make it, I don't know. Let's do something fun, 0.1. Okay, here we go. So this is 0.1 next. Alright, reload the map. Oh, now we have a tiny key. Look at that. Isn't that awesome? Okay. Alright, this is exactly what we wanted. Let's say that's what we wanted. Okay. Alright, so now we have a key, we have the size that we want, but say we want it back in this cave over here. By the way, this is the genius of ScriptHawk. You can use the D-pad to fast travel, basically. So let's say I want the key to spawn actually not over where it was, but over here. How do we update the position of it? Okay, well, we know the position is right here, and these are each floats representing the values that they are. And if you look over here on the left side here, this is where DK's position is. You can see my Y changes whenever I jump. XZ is moving along this plane right here. Okay, so say we want the key right here. I could go through the trouble of typing in 1333.856, getting the hex, updating it over here. But I have a simpler way that I like to do it, where if you look on the left side here, I keep pointing at my screen instead of using the mouse. So if you look over here, the player object is at 4452D0. So I'm just gonna go there, and this is dynamic, by the way. So this, depending on the map, it'll change. This is just a pointer to the player object. So, or this actually is where the player object is, but it's being updated based on where the pointer goes. So if I go here, this is where the player object is, and if I navigate to offset 7C from here. So 1, 2, 3, 4, 5, 6, 7, and then you go over C. This is the X, Y, and Z of where I am currently. And if you look, if I jump, oh yeah, look, there's the Y value updating in real time. And these are definitely floats. You can usually recognize a float because it's probably going to start with a 4 or a 3, like 3F or 4.0 to 4.4. That's a typical range you'll see for floats. Over time, you sort of get used to what they look like. So if I go in and I copy these three, and then I go back to where I was modifying, I'm going to update these floats right here to where I am currently, freeze those, reload the map, and then voila, let's see if it took effect. Oh, there you go. Look at that. Now I have a boss key spawned in this cave, exactly like I wanted. But you know, if I'm coming from this angle, it looks kind of weird that it's at that rotation. I kind of want to rotate it so that it's, you know, facing me whenever I approach it. So right now it's sort of, you just see the profile of it. Okay, so you can actually update the rotation of it here. So let's see. These three are the rotations. They're 0 right now, but these three are the rotation floats for this object. So rotation about the x-axis, rotation about the y-axis, and rotation about the z-axis. And from experience, I know that we probably want to rotate it on the x-axis to see a change. So let's rotate it 90 degrees. These values take floats from 0 to 360 typically. It's interesting. It takes a value from 0 to 360, but it takes it in the form of a float to actually be updated. So if I go over here and I type 90, this is going to tell me what 90 is. And then I can go in and say, okay, make the X rotation 90 degrees as a float right here. And if I reload the map, we can go check it out. Okay, that's better. It's not exactly what I wanted. I actually wanted it flipped the other way around. So instead of 90, what if we did, you know, 270? Okay, so let's get 270 and try it out. I have to reload the map every single time, by the way, because if you remember, these values don't actually update what even if the display over here, like if I were to go in and change the type, it might tell me that it's a new type. It might say it's not a boss key anymore, it's a coin or a tree. But in reality, it's not going to actually get updated for you unless you reload the map. And so that's why I have that save state that I used and updated the setup file at a very specific frame. And that's how we're able to do all this magic. And if you look, I updated it from 90 to 270, and it's doing exactly what we want. So yeah, let's do another example. Why not? Let's say we want to use the existing position of something else. What about like this rainbow patch? Oh, perfect. Okay, so the rainbow coin patch, not this one, but this one. This one is actually an actor. So we can show, what if we changed an actor? And now, actors and Model 2 objects are different. So the pool of things that we can spawn as Model 2 objects are not the same as things we can spawn as actors. So, like I can't spawn a tree in the place of an actor. So we're actually going to use a different list for this. Let me go to it as like a cannon, or why don't we spawn a boulder or something? Boulder is something easy. Not that, not that. I think this is what we want. Yeah, okay. So like, yeah, this is the list that we want. So 61, or this is actually decimal, this is 61. So let me pull up like a hex converter. Okay, so convert decimal to hexadecimal. So let's see, what is 61? I think it was 61, right? Yep, 61 is Boulder. So it's 3D. And knowing from experience, you actually need to subtract 1 from this. You need to subtract 1, 0 from it. So it's actually going to be 2D. But let's go to, so this is the one we want. Let's go to its spot in memory, 48A, 34C. Okay. So if we go to here, the type is also 2 bytes and it's at offset 32. So this is 0. So if I go down 1, 2, 3, and then over 2, that 07B over here is going to be its type. So if I update that 7B to, what is it, 2D? Yeah, 2D. Remember, it's whatever the value is over here minus 1, 0. And I can show you why. The actor types at the start are like for Kongs and, you know, like special stuff, load and zone controller, model 2 controller, etc. And it's not until you get to 17 where you start getting into stuff that you can actually spawn, like stuff that doesn't either crash or do nothing. And like if I were to change this right now to 1, it should show up as a cannon barrel. Let me see if that's right. Yep, see, spawner for a cannon barrel, type 1. But over here, it's listed as 17. So what you need to really do is, in your head, or just you need to subtract 16 from it. So, like I said, I want to spawn a boulder. So that's 2D, like we calculated. Now let's see. Yep, got that. So I'm going to freeze that, and I'm going to reload the map. And here I can just warp to it, see if it's updated. There you go. Instead of the rainbow patch, we now have a boulder, and we also still have the key. So as you can see, this is sort of the method in which you can progressively add things. Like say you want to make like a platforming challenge. This is the way in which you can say like add one platform and see if it's in the right spot, see if it's the right rotation, and be like, okay, now where can I jump from? Like say this is the starting platform of a challenge that I want to do, and then I want to go like, okay, where can DK backflip from here? And then say you get to a spot in his animation, be like, okay, I want to spawn a platform right here. Now we can do this example. This will be informative. So say the boulder is like the platform on which you want to backflip, and then I want to be like, okay, what if I had a metal platform, which I can look up the type of over here. Metal platform. That might be what I want. Is there another one? Yeah, this is the one that I want. Okay, say I want a metal platform at this position that I just found relative to the boulder. Okay, so let's find one of these to take over. I'm just gonna take over one of these flowers because they don't matter. 4A9624. Here you go. Okay, so this is a flower object. First thing I'm going to do is I'm going to change this from 39 to BF. See, now it's a metal platform. Right here. Okay, freeze that in memory. And then I go, okay, I want to have it spawn at this position. So I go 445 to D0. And then I'm just going to go to DK's player object and find his X, Y, and Z and copy that. Go back to, I think it's here. Yeah. And then I'm going to put this as its new position, freeze that, and say I want to go like, you know, I don't want it to be size 1, I want it to be size 2. I don't know what that looks like, but let's just try it. We can do this all at once. We don't have to guess. We don't have to update one thing and then check and then etc. We can try doing it all at once, see what happens. Okay, so I reload the map. It's a metal platform. Would you look at that? Okay, so, oh, yep, that's a pretty big platform. And can I get up to it? Hey, look at that. I just created my own little platforming challenge. You can see this is simple, and obviously this isn't very good. Like, this is not good level design at all. But this is mainly just meant to be a demonstration of like what you can do. Okay, so now that I've done all this, how do you actually modify the game so that this will be the way that this map loads every single time? Well, what we can do is, well, let's just go to the start of the setup file, which is at 4A91B4. Okay, so this is the start of it. And I'm just going to unfreeze all that stuff because that was just for demonstration. And well, first let me just copy down all the stuff that I did so that I don't lose it. So it's at 4A964. Okay, I'm just going to copy that, place it here. Don't worry about readability, it's just so I can copy and paste it. Okay, so I want the metal platform, I want the boulder, which is at 4AA34C. And it goes to here. Let's see, 1, 2, 1, 1, 2, 3. Yeah, 3A. Okay, that's right. I was just second guessing myself. So, let's see, this is the platform, this is the boulder, and one more thing we wanted the key, the boss key, which is at 4A93B4. So you might be able to tell by now that this is sort of a tedious process, because there aren't really any good tools to do this, but the fact that we can do it at all, I think is pretty great. And once you know what you're doing, this process isn't actually that bad. All the stuff that I'm doing, like I showed you pretty quickly how I was able to, jump from this boulder, find the position I liked, spawn a platform at the exact position that it was at, and change the scale of it essentially. It's an iterative process, but it if you have enough time on your hands, it's not that bad. All right, so let me just grab this. This is the 4A93B4. This is the boss key. Okay. So now that I have this, let's go and let's actually change the entire setup file. So this is all that spawns. And this will be important, because if we're able to change this so that only our stuff spawns, then we can copy exactly what we have in RAM and put it in a Hex Editor, and then I'll show you how you can modify a ROM so that this is exactly how it loads. And also conveniently, we're doing this in training grounds, so when I do end up loading a ROM with the modified setup file for this map, all I have to do is start up a new file, and then you should see it immediately. So it won't actually be that tedious to show off exactly what we did. Okay, so if you remember the way that the setup file is laid out in RAM, the first word is number of Model 2 objects. So if you remember, the platform and the boss key were Model 2, and the boulder is Model 1. So we want 2 of these. So this is, hold on, let me make sure that that's okay. So we want 2 of these, and we already know exactly what they need to be in order to be as we like. So I'm just going to copy them directly from what they were before and place them sequentially in RAM. So So we got the platform, we got the boss key, and that's the 2. Okay. So then next, after the Model 2 object, number of Model 2 objects and the Model 2 objects, we have the number of mystery objects. We're going to do 0. And then after that, we're going to have the number of actors, which we're going to do 1. Or I should say actor spawners. Okay, and then we have the boulder. So, okay, so now if I go back to ScriptHawk and I look at the map object feature here, it should only, see now it only lists the stuff that I just laid out sequentially. And this right here, this is what an uncompressed setup file in the ROM would actually look like. This is the entire file from beginning to end. So now that we know how to create something like this, we can just copy this, put it in a Hex Editor, use another program to compress it, put it at the right spot in the ROM, and from that point on, whenever you run that ROM, training grounds will always look like this, which I'm going to show you. So because there's only two Model 2 objects and 1 actor spawner, everything else is gone. And this is kind of important because you want to make sure, just as a note, you want to make sure that the size of the resulting file, so from here to here, this needs to be typically smaller than what it was previously. So previously I told you there were like 90 Model 2 objects in addition to a bunch of actor spawners. So obviously this is definitely going to be way smaller than the original file. But if you were to modify another map, there could not be very much. And then, at least for the time being, you're kind of out of luck for modifying those setup files for those maps. But most of the maps you're going to want to modify, they're going to have a bunch of stuff in them. Like main levels, they're going to have a ton of stuff, like warp pads, colored bananas, banana coins. You can just imagine there's like a ton of stuff in, Japes, Aztec Factory. There's just going to be so much stuff. And then even for something like Training Ground, there's just like so many random flowers everywhere and trees that we're able to do something like this. And as you can see, like some sort of light source was in here before that's not anymore, and now it's all dark in here. But the boss key's here, the boulder's here, and this platform is here. So this is going to be the goal. So we're going to take this right here and copy it, and then I'm going to open up my favorite hex editor, HXD, and I'm going to make a new file, paste in the contents from RAM, and voila. I'll just save it to the desktop for now. And I'm going to call this Training Grounds modified and uncompressed. Okay. So this is a good step. We have this. Now I want to show you a. This is an Excel file that shows the address in ROM of every single map in the game and their setup files. So let me just Control F and find like Training Grounds. Okay, so Training Grounds, is this the right one? Yeah. So Training Grounds is going to be at D36338 in, this is an address and it's in ROM. And I'm going to load up a program real quick to what the heck? Why is that not working all of a sudden? That's bad. Maybe I can just get it off the web real quick. just gonna download it real quick. I don't know why it's not working. What the heck? Even this new one is not working. Ah, well, that's annoying. Okay, I'm going to pause the video here and figure that out, and then I'll be back. Okay, I figured out what was wrong. I needed a bunch of C++ redistributables for this to work. Okay, so this is a universal game decompressor, which is really awesome, and it has a Donkey Kong 64 feature. So if I go in here, navigate to a folder which I have my Donkey Kong 64 ROM, and I hit open, you can see it's going to start decompressing all the files based on where they're laid out in the ROM. I already have all the files that I want, so I'm just going to cancel this. But by loading this ROM, I'm able to get access to decompress and compress file, which will use the compression algorithm that we need for Donkey Kong 64. So I'm going to compress the file that I just put in HXD, and I'm going to change this from modified to, or from uncompressed to compressed, because that's what we're going to do. And so it worked. So now we have a compressed file. So let's look at it. You can see it's a little bit smaller, and if it works, it usually starts with this like 1F8B whatever. If you look in the ROM, it's typically your way to sanity check and be like, okay, I know this is the start of a compressed file, because for whatever reason they all start with this little header. So what I'm going to do is now I'm actually just going to like put this in the ROM. We're already at that stage. So so let's see. So I'm going to, okay, so we need to know this address over here, because we need to know where to go in the ROM to find where the start of the training ground setup is. Oh, another thing we need to do first is keep this decompressor open, and I want to compress. If you go over here, I have an original training grounds map laying around somewhere. Not here. I think this is the original. Let me try opening it first. I think this is the original. Yeah, this is the original uncompressed training grounds file. So you can, yeah, if you remember, it had 5D Model 2 objects. So yeah, this is the one. So I'm going to compress this, and there's an important reason that I'm going to do that. I'm going to want to do that because I want to know exactly how big it is when it's originally compressed. So I can go into the ROM and I can zero out all of the memory associated with this and put something over it. So training grounds compressed. Original compressed. Okay. All right. So now we have that. I'm going to close this. I'm going to open original compressed. Okay. So originally it's pretty big. It's in size, it's 8D8. 8D8 is what we need to remember. So if I go here, this is a DK64 ROM, and I navigate to D36338, which is the setup file for Training Grounds. So I go to D36338, I think, and as you can see, 1F8B08, like I said before, that's a way to sanity check that we're at the right spot. And I'm going to use a hex calculator, just because it makes it easier, to tell me exactly where it ends based on the size of the compressed file. So if I take the original address and I add to it the compressed size of the original file, I will get the exact length of in ROM that I need to go in and zero out. So it's D36338 is the original address, and its size I said was 8D8. 8D8. And I'm going to add those together, and I get D36C10. So if I start here and I go all the way down to D36C10, which is right here, and you can see it's the start of another compressed file because 1F8B08, like I said. So these all need to go. I'm going to fill selection with 0. So now this entire block is zeroed out, and now I can put my setup file there that I just compressed. So I'm gonna, it's already open somewhere. Modified compressed, this is the one. So I'm gonna copy that. I'm going to put it right here. So now you can see, so I zeroed out the original compressed file and I put in my own compressed file. And this is what I was saying earlier, like you need to make sure that the compressed file size of your new file, it needs to be less than or equal to the size that it was previously. Because if I go down here, like I said, this is the start of a new compressed file. If it was going to be too big, it's going to start bleeding into some other file that I don't know what it is. It's probably another setup file, but or it could be something else in the map. Like it could be the level geometry or something like that. So in general, you're going to need to make sure that the compressed size is less than this block that I just filled with zeros. And by only putting in 3 objects, it easily met that criteria. So what I'm going to do is, this is now a ROM that has the setup file for Training Grounds that I just modified, and it's almost ready to actually run on console or emulator. I'm going to save this to the desktop as DK64. Oh, this is on the desktop. DK64 modified. I'm just going to say DK64 demo.z64. Okay. So I'm done with this. That's all good. Now, one last step. I'm going to use this file. Let me find it. This other application. I'm going to copy it here. Okay, it's called N64CRC. And what this does is CRC stands for, I think, Cyclical Redundancy Check. And basically what it does is it's an error correction algorithm that makes sure that the ROM is not damaged or modified. I think it's probably to prevent bootlegging of some sort. I don't actually know. But we need to run this program to make sure that anytime you mess with like a compressed, either compressed or uncompressed file, I'm not sure exactly. Basically, if you ever modify the ROM, just double check with yourself, or double check and run this program with the ROM. And basically all I have to do is go to desktop in the command prompt, and I want to run N64CRC, and I want to run it with the command line option of this new ROM that I just made, which is DK64 demo. Is it gonna work? Okay. Yeah, so there we go. Okay, so as you can see, it says bad fixed. So it's either going to say good or it's going to say bad, and then it's going to fix it. So this actually like fixed the ROM. So now the ROM will actually run. If you don't do this, sometimes the ROM will the game will just like not start. It'll just stay on a black screen, and you'll be sad, and you'll wish that you had run this program instead. Okay, so I'm going to close out all this stuff now and run my new ROM, and we'll see if it worked. It's a good start, good sign. I didn't fatally edit it in a way that it doesn't boot. Looks good so far. Let's full screen this. Got to get through the intro. And basically, all we're confirming at this point is A, does the ROM boot, and B, does the map that I just modified, does it actually show the changes? So let's go into training grounds. Just gotta watch this quick little cutscene, but this is a really good sign. I mean, look, there's no trees anywhere. So I did something. Oh. I don't have the benefit of all the ScriptHawk tools once I get into this new ROM because it's not supported, but would you look at that? This is look, you can see it. I'm running DK64 demo. It's in the title. That's my ROM, and everything is exactly as I laid it previously. Look at that. I just made my own amazing new ROM. And so this is a really simple example, but you can see with enough time and love, you too can go make your own conquest, like me. There's a lot of assembly that I did in that to, you know, sort of stitch everything together and make this linear hack that goes from training grounds to factory to fungi to japes to Crystal Caves lobby. Into Crystal Caves is the credits. And I definitely am not going to be able to fit in an explainer for writing your own assembly code for this game, especially not into this video. It's already pretty long. But I'm going to leave it here. That's how you modify the setup files in DK64. Yeah. And I'm going to leave a link in the description of well, first of all, I'm going to list all the tools that I used: GEDecompressor, N64 CRC, BizHawk, ScriptHawk. I don't know if I'm missing anything else. Oh, HXD for the Hex Editor. That's probably everything. And then also that spreadsheet that has all the addresses of the setup files in ROM. I'm going to also put that. I have my own GitHub repository where you can go check that out. I uploaded it. And so yeah, that's everything you need. And you know, if you have questions, some point down the road I might get with some people and see if we can set up a ROM hacking Discord or something. That'd be really fun to get people involved and get people collaborating and all that good stuff. That's the goal. That's why I wanted to make this video. So thank you all for watching. I hope I did a good job explaining. I'm sure people will have questions, but there you go. Enjoy. Thank you.